Okay, today let us discuss about VSEPR theory, valency shell electron pair repulsion theory. Most of the students feel that VSEPR theory is very difficult. Exactly speaking, it is the easiest among all the other theories. Very easy. Only thing what you need to understand, there is repulsion. There is repulsion between the electrons which are present in the outer shell. What do we call that outer shell? Valency shell. See, VSEPR means what? No, valency. It is valency shell electron pair repulsion theory. It's valency shell electron pair repulsion theory. You trust me. I'll make you understand this very easily. I've got so many other examples, tricky examples to understand this. There is no difficulty actually to understand VSEPR theory. Valency shell, valency electrons, right, which are in the valency shell, they experience repulsion. See, when you bring a north pole with south pole, they attract, but if you bring two north, they repel, two south, they repel. That is called repulsion. So that is a theory. Now this depends upon what shape of it changes the shape of covalent bond. Actually, it is studied to know the shape of covalent bond. Why the shape of covalent bond change, right? Why all the molecules, covalent molecules, do not have the same shape? Such an easy thing, isn't it? Why the covalent molecules, all the covalent molecules, do not have the same shape? Why? It is because of repulsion. Now let us understand. Now when you speak about this theory, you should know there are two types of electron pairs. Two types of electron pairs. The first electron pair is bond pair. Bond pair. Okay, first category. Second is what? Lone pair. First one. Okay, finish. Second thing, it is about how many pairs you have. Second thing you should know is, in each molecular formula, okay, there will be a central atom. We have to identify the central atom. So here I am going to take three things. One is, you remember them as MAO. Better you remember them as MAO. M means it is methane. Methane, and you know the molecular formula of methane, it is CH4. This is one. Okay, next one I will be explaining you about ammonia, and the molecular formula of ammonia is NH3. The last and final will be about water, WATR, water, that is H2O is its molecular formula. You know the bond angle in methane is how much? 109 degrees 48 minutes. In ammonia it is 107 degrees 28 minutes, and in water it is 104 degrees 31 minutes. Okay, right. Now carbon atomic number is how much? 6, 2 comma 4. What is the central atom here? Nitrogen. Atomic number is how much? 7, so it is 2 comma 5. What is the central atom here? Oxygen. Atomic number is how much? 8, 2 comma 6. You know here the valence electrons are 4. Here the valence electrons are 5. Here the valence electrons are 6. So around carbon, these valence electrons are represented. Now what is here? It is nitrogen. So valence electrons are 5. 5 means how many electrons do you require for satisfying 8 here? So you require 3. So 3 are kept down. Oxygen, when you speak about here, altogether 6, isn't it? 6 valence electrons, and here 2 should be satisfied in order to obtain octet configuration. So I am taking 2 hydrogens. Okay, 2 hydrogens. Here I am taking 3 hydrogens for the bond formation. This is hydrogen, this is another hydrogen, and this is another hydrogen. Right. Here I am taking 4 hydrogens because it requires 4 hydrogens. Hydrogen is also satisfied with the duplet configuration 2. Right. Now this is methane. Okay, this is a bond formation in methane. Now let us count on these things. Electron pairs. How many electron pairs do you find in methane? electron pairs. This is one pair, this is another pair, pair and pair. So you find 4 pairs, 4 electron pairs. How many bond pairs do you find? Bonded pairs. See, this is bonded, 1 pair, 2 pair, 3 pair, 4 pair, 4. How many lone pairs do you find? Lone pairs means pairs which are left free. Nothing, no lone pairs as such, all are bond pairs only, okay, all are bonded up. Now coming to this one. In ammonia, lone pairs are how many? Sorry, electron pairs are how many? Electron pair. This is 1 pair, 2 pair, 3 pair, 4 pairs. How many bond pairs do you find? Bond 1, 2, 3, therefore 3 bond pairs. How many lone pairs do you find? 1 lone pair. This is called lone pair. Now coming to water, electron pairs are how many? Pair, pair, pair and pair. So it's 4 pairs. How many bond pairs do you find? Bonded pair, pair and pair. So it is 2. How many lone pairs do you find? Leftover pairs, not bonded ones, 2. So coming to this theory, valency shell electron pair repulsion theory, the main concept of this theory, do you know? The main concept of this theory is lone pair repulsion is greater than lone pair bond pair. Lone pair bond pair repulsion is greater than bond pair. What do you understand by this? Can you tell me? If you find more number of lone pairs, repulsion will be more. What happens if repulsion is more? Repulsion is inversely proportional to bond angle. Repulsion is inversely proportional to bond angle. That means if the repulsion is more, bond angle is less. See, if lone pair repulsion is more, where do you find 2 lone pairs? Here. 2 lone pairs, okay? Therefore, bond angle should be less here. Exactly. Bond angle in methane is 109. In ammonia it is 107, in water it is 104. See, here only 2 bond pairs, 2 bonded ones. But what happened? Bonded ones are just 2, but angle is less. Here bonded are 4 bonded, but the angle is more. Why? Because this theory is not speaking about number of bonds, it is speaking about lone pair and bond pair repulsion. So if lone pairs are more, repulsion will be more between the lone pairs and the bond angle will be less. Here you don't find a lone pair, no lone pair at all in this case, no lone pair, repulsion is less, bond angle is more, that's why it is 109, right? When you speak about this one, it has got 1 lone pair, so it comes under this category. Now just refer these two. Here lone pairs are too many, 2. That means here more lone pair, then repulsion is more, bond angle is less, exactly 104. Compared to water, ammonia has only 1 lone pair, so it comes under this category. So we are speaking about these two. This is in case of water because you have 2 lone pairs, right? This is in case of ammonia. Here you have only 1 lone pair. 1 lone pair means repulsion in this case is less than water because water has 2 lone pairs. Repulsion in ammonia is less when compared to water. Repulsion is less, bond angle is more, exactly 107 and this is 104. Did you understand? I will explain you in a different way. This is understood clearly. Now the other way I will try. Okay, that will be much more easier for you to understand. Now let us take example. I will explain you in a different way. Let me take oxygen. So oxygen has got how many valence electrons? 6. So let me represent them like this: 1, 2, 3 and 4. Then one more is here and one more is here. So 3 plus 3 is 6. So one is bond, this side one bonded with hydrogen, this side also one is bonded with hydrogen. So like this, imagine like this it is. Why not like this? Why not like this? This can be an angle of 180 over here, 180. But it's not like that, it is just 104. Why? Because very clear, no? Just imagine that these two, this is called lone pair, this is called another lone pair. He is telling that the repulsion between lone pair is large. So these 2 lone pairs will not stay here actually, they won't stay here because there is a repulsion between these two, Therefore what happens, this is the actual structure. See, these two will not stay here because more than bond pair, lone pair. The repulsion is more between lone pair and lone pair. Therefore, lone pairs will repel each other. Actually, they are supposed to be here. They are supposed to be here, but they repelled. Right? Just imagine that there is a fight between lone pair, lone pair. So they took a decision that they don't want to see their faces each other. So what is coming in the middle is oxygen. Now previously what was here, man? Hydrogen is here. So they are pushed down. They are pushed down. Hydrogen is pushed down. Why hydrogen is pushed down? And moreover, when it is pushed down, what happened to angle? Decreased. Angle decreased. Why did it decrease, man? Why did the angle decrease? Because lone pairs are there. Two lone pairs. That means lone pair repulsion is greater than lone pair bond pair, and lone pair bond pair is greater than bond pair. Therefore, in this case, repulsion is more. So instead of staying here, since they repelled, this came this side, this one has come this side. So when they repelled and came down, these two which were here, these two which were here are pushed down. So more the repulsion, lesser is the angle. That's what it is. More the repulsion, lesser is the angle. That is why you see here, there is no lone pair. There is no lone pair at all. Their bond angle is more. 109 here. It is 107, 104. Why it is 104? Because it is having two lone pairs. Lone pair repulsion is more. Therefore, bond angle is less. When you speak about this one, what it comes under second category. It has one lone pair, only one lone pair. So repulsion will be less compared to this one. Here the repulsion is more. Here the repulsion is more. Two lone pairs. Here the repulsion is little bit less than this one. Therefore bond angle here is more. Now coming to this one, there is no lone pair. Lone pair is not there in methane. Lone pair not there means just bond pair, and the repulsion is least. See, least. This is highest. So bond pair, least repulsion, bond angle is more. That's why it's 109. Okay. Here you have one lone pair. Right. Therefore, it has an angle more than water. Why? Because in water there are two lone pairs. Lone pair repulsion is more. Right? Instead of staying here, these two, they come here because they don't want to see their faces. Just imagine like that. There is a fight between these two. Why? Because it is told, VSEPR theory says that the repulsion, lone pair repulsion is more. So instead of staying here, right, they have come down. They don't want to see each other's face. Imagine. Therefore, what was here previously? Hydrogen was here. Therefore, hydrogen is pushed down. In this way, we get the difference in the shape as well as bond angles.